All right, we should be good. So, hey everyone, I hope you're all doing well today. Thanks for joining us as we talk about what's new in Azure Firewall. My name is David Frazee, and I'm a product manager on the customer experience and engineering team for Azure Network Security. And so joining me today is my colleague, Gustavo Modena. Today, we're going to talk about some of the new features that have recently been released for Azure Firewall. I'm excited to share these new features here today since we always get a lot of great feedback from this community, and it's through your voices that we're really able to improve and drive Azure Firewall to where it is today. If you do have any questions during the presentation, please feel free to put them in the chat as we present. We do have a great team joining us today that will be monitoring the chat, and they'll try to do anything that they can to answer those questions. As mentioned before, if we have time at the end, we'll take some moments to address any unanswered questions or questions that would be really beneficial to the community. All right. All right, so for today's agenda, we'll have an overview of the Azure Firewall to cover features and capabilities. I'm sorry, I'm over here sharing sharing that over there. So for today's agenda, we'll have an overview for cover features and capabilities, as well as potential use cases of when to deploy Azure Firewall. Then we'll go into our newly released features for monitoring, like latency probe, flow trace, top flow, and a refreshed Azure Firewall workbook that uses structured logs over Azure Diagnostics table. Next, we'll talk about management features like O365 FQDN and service tags, explicit proxy, and policy analytics. Then Gustavo will then demonstrate these features in Azure, and we'll close it out with a Q&A. So we'll get started with an Azure Firewall overview. So the Azure Firewall is Azure's first-party next-generation firewall with built-in high availability and unrestricted cloud scalability. It's a fully stateful firewall that provides both east-west and north-south traffic inspection for your environments. So Azure Firewall comes in 3 different SKUs. There's basic, there's standard, and then there's premium. The basic SKU is intended to deliver the essential protections small and medium-sized customers need at an affordable price point. But it can be used by larger enterprises with, let's say, smaller lines of businesses or other use cases. They might just need very standard layer 3, layer 4, and layer 7 protection for their environment. So basic SKU could be used there. For the standard SKU, it is recommended for customers who are looking for that layer 3 to layer 7 firewall that needs the auto scaling, and it can handle peak traffic periods of up to 30 gigabits per second. Standard SKU also, it does support enterprise features like threat intelligence, DNS proxy, custom DNS configurations, and web categories. Lastly, the premium SKU is recommended to secure highly sensitive applications in regulated environments, such as payment and healthcare industries. It supports advanced threat protection capabilities like intrusion detection and prevention, TLS inspection, and URL filtering for application rules and web categories. This premium SKU can handle up to 100 gigabits per second of network throughput and up to 10 gigabits per second for fat flow support. Azure Firewall utilizes at Firewall Policy, a global resource that can be used to centrally manage your firewalls using Azure Firewall Manager. So this is really where our rule creation, management, and the additional features and configurations that we're talking about today will be available. So Azure Firewall can fit neatly in a few different use cases when running environments in Azure. If you want to secure traffic from your Azure environment destined to the internet or vice versa, internet coming into your environment, Azure Firewall can sit in a nice centralized hub and be your egress and ingress point for the environment. If you're currently using, let's say, multiple cloud providers and you have a direct private path to that other platform with the VPN tunnel, you can inspect the traffic that's going to and from that third-party provider through that Azure Firewall. Similarly, when you establish hybrid connectivity with your on-premises data centers and your main corporate offices, maybe you're using ExpressRoute or VPNs, you can inspect the traffic to and from the on-premises workloads as well. The Azure Firewall can be used within the Azure environment to inspect traffic that goes from one virtual network to another virtual network. And so these firewalls, they are deployed to a virtual network hub in different regions, Or if you wanted to deploy this into an Azure Virtual WAN hub to inspect any and all traffic entering the vWAN hubs, you can do that with the Azure Firewall. It will fit neatly in the middle to secure your traffic to these different endpoints that you see here on the slide. All right, so now let's get to our monitoring features here. So first we have the latency probe metric. This was recently released for public preview, and this metric is designed to measure the overall latency of Azure Firewall and provide insight into the health of the service. So IT administrators, they can use the metric for monitoring and alerting if there is observable latency and diagnosing if the Azure Firewall is the cause of the latency in a network. In the case that Azure Firewall is experiencing latency, this can be due to various reasons such as high CPU utilization, traffic throughput, or possible networking issues. As a reference, the average expected latency for a firewall or an Azure firewall is around 1 millisecond. So this may vary depending on the deployment size in the environment, but typically what you'll see or what you should expect is around 1 millisecond there, as you can see in the screenshot. So to be clear, though, this metric does not measure end-to-end latency of a given network. It is a ping mesh of the firewall instances. So in other words, this latency health probe, it will not measure how much latency the Azure Firewall has added to the packet flow. This metric is enabled by default. So if you have Azure Firewall deployed today, you'll be able to see it already in the Azure portal with the drop-down menu. Next, we have the flow trace logs. These were also released in public preview. These logs allow IT administrators to see traffic return flows, failed connections, or unrecognized packets hitting the firewall. Currently, the firewall logs, they show traffic through the firewall in the first attempt of a TCP connection, which is known as that SYN packet. However, this doesn't really show the full journey of the packet in the TCP handshake or our three-way handshake here. So as a result, it's really difficult to troubleshoot if a packet is dropped or if there's asymmetric routing somewhere within the path. So this log will capture the following flags to help you with your troubleshooting efforts. It will capture syntax, fin, finax, resets, and invalid flows, or it'll just say invalid here. And so invalid indicates that a packet can't be identified or it doesn't have any state in the firewall's table. This means that the Azure Firewall, it may have received maybe a SYNAC packet, but it never saw the original SYN packet. This is really a clear sign of asymmetric routing. And so when that does happen, we will log that as an invalid flag in the Azure Firewall logs. So to avoid excessive disk usage, though, it is recommended to activate the logs only when troubleshooting a specific issue for diagnostic purposes. So flow trace logs, this really is just for troubleshooting network paths, network flows. So if you don't have a network issue at the moment, just recommend you don't enable that you don't turn that log on and start ingesting that log until it's absolutely necessary. But there are some prerequisites to actually enabling this new log, so it's not terribly difficult. You'll be able to get operational with these rather quickly. So first, you'll have to have structured logs enabled in your Azure subscription. One of my teammates, they can add a link to Azure Firewall structured logs in the chat to show you how to accomplish that prerequisite. It's not difficult at all. It's fairly easy. You'll then use the Azure PowerShell commands on the slide to enable the flow trace log. It can take several minutes for this to take effect. And once the feature is completely registered, you'll perform an update on the Azure Firewall for the change to take effect immediately. If you have time, you don't need to wait immediately, or you don't need to go into troubleshooting instantly, then you can wait and will work. But just a quick, get set on the Azure Firewall after this command, and then everything will take effect immediately. If you want to check the status of this resource provider registration, you can run the Azure PowerShell command get-az resource provider feature, and then just use the same feature name and provider namespace values that you see in the screenshot here. Once you have this enabled, create or edit your diagnostic setting and select the flow trace log, and then ensure that that diagnostic setting is pointing to resource-specific tables and not the Azure diagnostic table. All right, so sometimes traffic flows can either be unintentionally or intentionally heavy, depending on the size, the duration, and other factors of the packets. Although Azure Firewall Standard can support up to 30 gigabits per second and Premium can support up to 100 gigabits per second, these flows can potentially impact other flows and the processing of the firewall. So it's important to monitor these traffic flows to ensure that the firewall can perform optimally. The top flow logs, also known as fat flows, shows the top connections that are contributing to the highest bandwidth in a given time frame through the firewall. In our example screenshot here, our column named flow rate is the column that will show the bandwidth consumed between the source and destination pair. This flow rate is measured in megabits per second. So, in this screenshot, in this example, our first log here shows a flow rate of 0.069, which will equate to around 69 kilobits per second. So similar to flow trace logs, only enable top flow when troubleshooting a specific issue to avoid excessive CPU usage. Enabling this this public preview log is very similar to flow trace log, except we're enabling the feature on the firewall itself and not on the subscription. So prerequisites are the same. Structured logs must be enabled, and the diagnostic settings need to target resource-specific tables instead of Azure diagnostic tables. And then once the prereqs are met, follow the Azure PowerShell commands in this example, and you'll be able to use this log immediately. The Azure Firewall Workbook. This actually provides a flexible canvas for Azure Firewall data analysis. You can use it to create rich visual reports within the Azure portal and to tap into multiple firewalls deployed across Azure. This workbook visualizes security relevant Azure Firewall events across several filterable panels. It works with all Azure Firewall data types, including the application rule logs, network rule logs, DNS proxy logs, IDPS, and threat intelligence logs. You can deploy this through our public GitHub repo at aka.ms/aznetsec using the deploy to Azure button, or you can import really using the ARM template or the gallery template. This workbook is using the new Azure Firewall structured logs, which are the recommended log tables for their ease of use and their performance. If you're already using structured logs in your environment, you'll now be able to use this workbook fully, just deploying the one that is labeled for structured logs here. All right, so now that we've covered the monitoring features, let's just take a look at some newly released features that can help us with Azure Firewall management and managing our environments. All right, so you can use the Azure Firewall built-in service tags and FQDN tags to allow outbound communication to Office 365 endpoints and IP addresses. For each Office 365 product and category, Azure Firewall will automatically retrieve the required endpoints and IP addresses and then create the tags accordingly. So this will all be done dynamically in the backend. You won't have to manage this. All tag names will begin with Office 365 and are followed by the products like Exchange, Skype, SharePoint, and then maybe, I believe, Common as well. After the product will be a category for either optimize, allow, or default. And then some tags will have optional fields appended like required and not required. There are two tag types. There are the FQDN tags. FQDN tags represents only the required FQDNs or fully qualified domain names for the specific product and category that communicate over HTTP, HTTPS, or port 80, port 443, and can be used in application rules to secure traffic to these FQDNs and the protocols. And then we have service tags. And service tags will represent only the required IPv4 addresses and ranges for the specific product and category, and they can be used in network rules to secure traffic to these IP addresses and to any required port that might be necessary for that communication. Tags are updated automatically with any modifications to the required IPv4 addresses and FQDNs. New tags might be created automatically in the future as well if new combinations of products and categories are added. Nothing will have to be done by the user if that is the case. You should just see these tags dynamically show up in the list. When you do create the rules, ensure you define the required TCP ports for the network rules and the protocols for the application rules as required by Office 365. If a specific combination of products, category, and required not required have both a service tag and an FQDN tag, you should create representative rules for both tags to fully cover the required communication. So what that was pretty much saying is that if there are some services that will require traffic outside of 80 and 443, and you do need to use a network rule for that as well, please use both the network rules with service tags and the application rules with FQDN tags to really cover this entire the entire environment. Application rules can only cover HTTP, HTTPS, or MS SQL. So to allow communication to these FQDNs, create your own network rules with these FQDNs and ports. And you'll be able to do that using FQDN filtering in the network rules. Explicit proxy is a new feature that has recently released as public preview. Azure Firewall operates in a transparent proxy mode by default. And so in this mode, traffic is sent to the Azure Firewall using a user-defined route configuration within a route table. The firewall intercepts that traffic inline and it passes it to the destination. But with explicit proxy, you can configure a proxy setting on the sending application, such as like a web browser, with Azure Firewall configured as that proxy. So as a result, traffic traffic from the sending application will go to the firewall's private IP address and therefore egress directly from the firewall without the use of that UDR. You can manually configure the IP address on the browser or application, or you can configure a proxy auto-config file or a pack file. Firewall can host a pack file to serve the proxy request after you upload it to the firewall. If you do use the pack file, you'll have to store this in an Azure storage account and then give read permissions through a shared access signature URL or a SaaS URL. And then whenever there is a new change made to the pack file, so say there does have to be a change, you will need to generate a new SaaS URL and then apply that to the Azure Firewall. So if there are any changes to the pack file, just be aware that you'll have to just go back and generate a new SaaS URL. But once that's in there, you should be good. So lastly here, I'm excited to announce that Policy Analytics has gone generally available. Policy Analytics provides insights, centralized visibility, and control to Azure Firewall. IT teams today, they're really challenged to keep firewall rules up to date, manage existing rules, and remove unused rules. And an accidental rule deletion or update can really lead to a significant downtime for IT teams. For large geographically dispersed organizations, manually managing firewall rules and policies, this is a complex and sometimes error-prone process. The policy analytics feature is really the answer to this common challenge. You can now refine and update firewall rules and policies with confidence in just a few steps with the Azure portal. Some of the key features of policy analytics are the insights panel, rule analytics, traffic flow analysis, and single rule analysis. These features aggregate insights and highlight relevant information, analyze existing rules, and identifies low rule utilization, maps traffic flows to rules by identifying top flows, and allows a single rule analysis to learn what exact traffic hits that rule to further refine the access. And so that's Policy Analytics, a really powerful, great tool for teams to use to optimize their Azure Firewall policy. All right, so now I'm going to pass this over to Gustavo for a demonstration.
Hey, David, thanks. Hey, everyone, thanks for joining us today. Let me, hold on a sec. Yeah. All right, please, I think you all can see my screen now.
Yeah.
So today we're gonna, I'm gonna be showing you some of these features that, David just presented. And, let's start from the new logs and with the metric logs, right? So for the metric log, the new metrics showing the latency, you don't need to enable anything. If you have your firewall deployed, that feature has been it's already available for you. You don't need to enable any flag, anything like that. And to be able to see that metric, you need to come here and then select latency probe. You see this metric still in preview right now, and then the aggregation is just average, right? So this is pretty much showing the latency between all the instances you have, on your active on your Azure Firewall. So if we see any kind of degradation on the instances, causing a high latency on while running the health checks, we're going to see these spikes here, right? But even this spike here is not something that I should be concerned for two reasons. The first one is that this is, as I said, just a spike. It's not, staying high. And this one specifically is not even close to 1 millisecond, right? So the idea is, hey, if you are, seeing something like higher than a millisecond for a long time, then it could be causing some performance issues for you and for users, right? So you can even zoom in and zoom out in this chart here to see more details. You see when we zoom in, the values get closer to what it really was. And then this one is was on a spike between 120 140 milliseconds, and then if you zoom out, it will probably go down because of the average between these 24 hours is window that I'm looking at. But yeah, if you can even create alerts. So let's say if you want to get alerts when the latency is higher than, let's say, 3 milliseconds, 4 milliseconds for the specific time frame, then you create this alert here to send you an email, and then you can see, or at least correlate when you have performance issues with these events being alerted and sent to you. But yeah, that's pretty powerful. It doesn't, even though it doesn't show the end-to-end latency or the latency added by the firewall, it gives you a great visibility of, to correlate when users are complaining about performance. So if you have that kind of situation, you can come here, take a look at the metrics, if there is something indicating performance issues here, and then you can work with our support team to understand, or to, yeah, really to understand what's going on and why the instances are, the latencies are high. That's it for the metrics. Then for the logs, right? So David mentioned about the flow trace and the fat flow logs, right? So the flow trace needs to be enabled at subscription level. And like David was saying, after you enable the feature, it's important to run a command just to make sure that your subscription is really ready to use that feature, right? So the command is this one. So this command here is going to show you if the feature is registered or not, right? So you run the get AZ provider name feature, and then give the feature name in the provider namespace. It will tell you if the feature is already registered or not. If you just ran the command to enable the feature flag, then it should take some time to to finish the registration, and then you're supposed to run some kind of update on your FIDO to have the changes taking effect right away. So, but yeah, run this command, make sure you're seeing the registration state as register, and that's good. Then you're good to start using the logs in your environment. Then for the fat flow, it's a little bit different because the fat flow is on firewall level. So if you're deploying new firewalls, you need to make this change on every single firewall while it's in public preview, right? And the way you can do after running the PowerShell commands to make sure the feature has been enabled, you come here on the portal and then click on this JSON view. And under this JSON view, you'll see these additional properties here. And then you'll see if the fat flow logging is true or not. So in this case, it's already enabled, so it's showing the value as true. So with these two, different methods, you are able to confirm the features are ready to start using. But then the next thing you need to do is go to the diagnose settings and enable or create a new diagnose settings using the resource specific logs and selecting the two categories for fat flow and flow trace. In this case, I already have my diagnose settings here, so I would just click edit to show you what are the categories that I'm talking about. So these are the two categories, right? So the first one, Azure FIDO Fat Flow log. The second one, Azure FIDO Flow Trace log. These will, once you enable these two categories here, make sure you are sending the data to the destination table resource specific, because this is one of the prerequisites mentioned by David as well. Once this is done, you're ready to, your FIDO will take some time to start sending the logs and populating the log analytics workspace. But then when you have that enabled, you can easily come to the logs and then start filtering. The first query that I will use here is to show the flow trace logs, right? So this in this query here, I'm pretty much saying, hey, I want to see the logs. Let's say, let me give you the scenario first. So this is the scenario of an asymmetric route, right? So I have two VMs in a single VNet, and then I have, in this case, I have the 10.10.0.132 sending a, SYN packet to the 10.10.0.68. But then the 10.10.0.68, which is in the client subnet, has a UDR sending the traffic to the Azure Firewall, right? So what's causing the asymmetric route? Because the first packet from the 132 to the 68 goes directly to the VM, but then the returning traffic, the CNAC packet, instead of going directly back to the 132, is going through the FIDO, causing the asymmetric. And the FIDO is pretty much dropping it because it doesn't know the state of this traffic here. So in this case, when we go back to the logs, then I'm saying, okay, I will filter this table here, which is the table for the flow trace. And then I want to see where the flag is invalid. And I'm just putting more information about the source IP. In this case, the 68 returning the traffic back to the 132. That's why in that case, the 68 is the source IP. And then the source port is 3389, because the test that I was doing was, 132 talking to 168 on port TCP 3389. And then when I run these, in the last 24 hours, I will see all the packets. Something went wrong here. Let me remove this. Valid. Oh yeah, it's working. So yeah, in this case, I'm seeing a lot of packets indicating, with the flag invalid, and then showing the source IP, the 10.10.0.68, responding from the 3389 back to the ephemeral ports here on the destination side, and then the flag showing invalid. So it means that, this packet was dropped because the FIDO never saw it doesn't know the state of that connection. So that's a pretty good, tool to use and help you identify why, some connection is not working properly, and then it gives you the visibility if there's something being dropped due to, let's say, for example, the asymmetric routing. All right, then the next one is for the fat flow. For the fat flow, we're gonna query a different table. So this is the query that I'm gonna use here. And what I'm pretty much looking here is, in this case, I'm looking for communication connection on port 445 that took, the flow rate was higher than 5 megabits per second, right? Let's run this for the last 48 hours, and let's see what we have here. Okay, so I have 1, 2, 3, 4, 5, 6, 7 lines from 1:51 p.m. until 2:18 p.m. It was yesterday, right? So what's going on here? At that time, I was doing a file transfer by using port 445, which is SMB. From one VM to another, this was east-west traffic, right? And then here I'm seeing these 7 lines for the same file transfer. Why do I have these 7 lines if it was just one file transfer, just one connection established? The process we have behind the scene is that the FIDO is calculating, is checking the VM, the interface, and then grabbing the data every 3 minutes, right? So that's why we're gonna have different lines here for different with different timestamps, and then even still seeing the same destination port, the same source port. So it depends on how long your file transfer or your connection was established and active, and if the flow rate during that time was higher than 5 milliseconds or not. So if your connection takes more time, you would probably be seeing more lines here, but that's how we are calculating and capturing the flow rate for for your for the connections. And that's why we recommend to enable these when you are troubleshooting some performance issues or when you are trying to identify what are the top connections, using creating the most fat flows, because it takes time. It requires resources on the FIDO side to process and calculate all of these and then make the information available. All right, so next one we're gonna go to, let me see here. Yeah, just to let you know, one other thing on the asymmetric routing scenario, right? So these are the tests that I was running. I was running just the TCP test net connection on port 3389. You can see here where it was working. I is from when I had the route table associated with the subnet here, and then I removed the route table and the traffic started going directly from one VM to another, then it's when I started seeing the failed the drop packets being dropped here, because because of the symmetric routing that I caused. All right, so the next one that I want to talk about is the explicit proxy. So for the explicit proxy, we need to go to you need to be using FIDO policy, and when you're using the FIDO policy, you have the option to enable the explicit proxy. The advantage of using the explicit proxy, let's say, uh, for example, you have a web application that needs to where you need to start inspecting the traffic from that application to the internet or to somewhere else, and then you don't want to add any kind of UDRs to change the routing behavior in your subnets, so you're going to be using the Azure Firewall to be your explicit proxy in this situation. To enable that, you go to the FIDO policy, and then on the left hand side, you're going to see this explicit proxy preview. In the explicit proxy preview, when you enable it, you need to provide what's your HTTP port and what's your HTTPS port. If you're going to use the pack file, you need to enable proxy auto configuration and then provide the SAS URL of your storage account. And then what's the port that the storage account will be listening to receive connections for the pack file. In this case, I'm not using the pack file, so I only have the explicit proxy enabled on 8080 and 8443, and that's it, right? What else I need to do on my side is I need to go to the application or to the VM, and in this case, I'm pretty much using a VM. Sorry, here, what's happening? Okay. I'm pretty much using a VM. And what I want to show you here is that let's say I want to try to, I just want to show you the behavior here. So I will start a packet capture. I'm not gonna save this, and I will try to go to superdownloads.com, right? So we can see here, let me stop the capture and let me run this filter. So if I run this filter here to say, the destination IP of when I connected to superdownloads.com, I will see the IP address is 199.59.243.223, right? Which is a public IP, and in this case, it means that this VM is connecting to the internet without going through the firewall or something like that, right? Then if I come here to the internet options and then I make a change in the connections to, in the proxy, I will say, okay, use proxy server. And then in the advanced, I need to make the changes here. So it's for HTTP and secure, I'm using port 8080 and 8443. So that's the configuration that I will have now. And what happens now if I try to establish this connection, I'm being denied because in this case, the traffic is now going through the Azure Firewall. Let me just start a new one here and I will do this again. Let me stop the capture. So we see here the destination IP address in this case is the 10.10.14, which is the IP address of my Azure Firewall, right? So it is the private IP address of my Azure Firewall. So in this case, we know the traffic is going through the firewall for two reasons. The packet capture is showing the destination IP being the firewall IP, and then in this case, my rule is blocking, traffic to download websites that are, categorized as download websites. And but yeah, and what do we need to do on the firewall policy side to make it happen, right? So we already have the explicit proxy enable. So the other thing that we need to do is go to the application rules and have the rules allowing the traffic to whatever you want, right? So in this case, I have one rule for explicit proxy, and then what I'm using here is the web categories, allowing some specific categories here. And we can see that downloads, there's a lot of categories that are not enabled, and downloads is one of the ones that are not enabled here. So that's why I'm being blocked there. If you are using explicit proxy, you have to have to be using application rules. It doesn't work if you configure the network rule allowing connection from any to any. So for explicit proxy, it will not work. So you must have the application rules configured there to allow you to use the explicit proxy and have the traffic being allowed by the firewall. All right, so I'm not going to show anything specifically for the O365. I just want to show here where you're going to find it. So in the application rules, you will see the O365 and Windows Desktop, tags here. So you'll see these new Windows Virtual Desktop, Citrix HDX. You're going to see these new FQDN tags. And remember, as David was saying, for the application, it only allows traffic on HTTP, HTTPS, or MySQL. If you need to allow traffic to those IPs using different ports or to those FQDNs using different ports, you should be using network rules. And then in the network rules, you also see in the service tags, you'll see the options for O365 down here as well. Okay, not these. It serves tags, yeah, should be here. 365, yeah, these are the ones for 365. All right, then next up we have the policy analytics, right? So for policy analytics, when this feature was released in public preview, we were required to run a PowerShell command to enable the feature flag, right? So since it's being released in GA now, you don't need to run the PowerShell commands anymore. The only thing you need to, do is come to the policy analytics under your Azure Firewall policy, and then configure workspaces, enable the policy analytics, and pick the log analytics workspaces where you have the diagnosis data logs being sent to, and then you'll be able to start in the policy analytics for having let's say the insights tab shows you some give you some visibility of the limits. If you are getting close to the limits, it shows if you're using multiple IPs, static analysis, some static analysis here, generic rules if you're using wildcard on source and destination IPs, and even if if you have rules that have low utilization, and then from here you can get to know the rules and the matching flow you have per rule, and you can also see the traffic flows. It really helps you to identify a number of flows and top talkers in these cases. And the single rule analysis helps you identifying if there are improvements that you can do in your rules based on the logs that you are sending to the log analytics workspace. So the policy analytics depends on the structure logs to work, and all the data that you have in your log analytics workspace will be used by the policy analytics to run the analysis on the rules and give you recommendations on what you can change to make your firewall and make your rules more secure. Not so not allowing many ports that are not in use or many IPs that are not seen in the logs. I think that's it for the demo. I hope you guys enjoy it, and I think we can go open the floor for questions.
Great, thank you, Gustavo. The team's been great with answering questions. We do have a couple to reiterate. The first one is HTTPS traffic decrypted to accomplish deep level inspection?
Yes, that's a good question. It is available in the Azure Firewall Premium, and you can use the TLS inspection to decrypt the traffic, and it helps with the if you are using TLS inspection with IDPS, for example, you can decrypt the packet and inspect the full URL. It helps on URL filtering and also identifying threats in HTTPS traffic.
Great, thank you. The next question we have is, can the logs be sent to an event hub to have them forwarded to a third-party SIEM?
Yeah, that's possible. The only thing is that if you were looking to use the logs for policy analytics, for example, you have to be using the log analytics workspace. You need to have the data in the log analytics workspace, as that's part of the configuration when you are enabling the policy analytics. But if you want to send it to an external data SIEM, you can pretty much use the event hub to send the logs to an external part.
Great, thank you. That seems to be all the questions that we have for today. So with that, I'd like to thank you, Gustavo and David, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute to submit your webinar feedback at aka.ms/AzureNetSecFeedback. Thank you, and see you next time. Goodbye.